So, hello everyone, this is your host Anant, and we'll be learning about what, like, let me just give you a brief intro about myself first. I am Anant, and I am a BTech student at JP Institute of Information Technology in Noida. And the reason I'm starting this channel is like not to not that I'm a tutor or something. It's just I want to keep a record of my progress, and I believe that the best way, like सबने you all must have learned this heard this line or quote, whatever you call it, that the best way to learn is to do it by teaching someone else. So what I thought, why not give it a try? And this is the background. This is my hostel room basically. So the first topic that we'll be learning today is graphs. So I'm in the third semester of my college, and we have finished trees and all, and I thought like we should start learning about graphs because that is a crucial topic from the point of view of interviews as well as competitive programming. So I'll try my best to deliver the best to you guys, and because I'll try to deliver because I'll be delivering whatever I'll be learning. So everyone tries to learn the best. So that's a promise that I'll deliver the best to you guys. So what are graphs? What exactly is a graph? So we can think of graph as anything like, why is this tool not working, bro? It is working, okay. So we can think of a graph as nothing, well, like we all must have, you all must have learned about trees. So trees are a special case of a graph. They are undirected acyclic graphs, and we'll be learning about the types of graphs later on in this video. This is just an introduction video. So a graph is a non-linear data structure with vertices and edges. The vertices are connected to each other by through edges. So this is a non-linear data structure, so there are different traversal techniques for the for graphs, unlike arrays. Like we had different traversal techniques in trees, there are different traversal techniques in graphs as well. So before moving on that onto that part, we'll be learning about the different types of graphs. So what are the different types of graph? Let me just put out this annotation thing, toggle it off. How do I toggle it off? Like, I'm using this tool for the first time, so I might have trouble using it, but never mind. Okay, so that's it. Where did our board go, bro? This is so a graph is as I spoke, a graph is a non-linear data structure made up of vertices, nodes, whatever you call it, and edges that represent a relationship. So this is how you represent a graph. G vertices, V is the number of vertices, and E is the number of edges. So based on different criterias, we can categorize graphs into different categories. The first one being based on edge direction. So what do we mean by edge direction? Let me just draw a simple graph. This is a graph. Never mind when drawing. Okay, so this is a graph. If I connect these vertices and don't mark the direction on these edges, then this is what we call an undirected graph. The relation, this edge, let me just name these vertices as well. This is, suppose we call it A. This is very difficult, yeah. B, and this is C. So these are the vertices. So this edge between A and B will be counted as a bidirectional edge. It is not directed. That is what we mean by undirected. That is as simple as that. And if I just add an arrow here, here, and here, this is a directed graph now. So that is the simple difference between undirected and directed graph. That's what is written here. And in directed graphs, you cannot say that this edge is between, although this edge exists between A and B, but you can only move from A to B, not vice versa. Okay, that's a basic difference between undirected and directed graphs. Moving on to the next category, we have weighted and unweighted graphs. So now let's move on with this diagram itself. If I add, like, in the, at present this is a unweighted graph. What are weights? If I add some number over these edges, then that could be anything. That could be cost, that could be the distance between the vertices, whatever you that if I add a simply add some number here, 6, 7, okay, 7, 1, then this becomes a weighted graph. These weights could be negative as well. We'll be learning about that in detail in the upcoming videos. So this becomes a weighted graph now. This is of importance when we learn about shortest path algorithms or the other algorithms. So moving on to the next thing, based on cycles, there could be acyclic and cyclic graphs. When this was this is a cyclic graph. You can start from this node and follow this path and end up reaching back to this node A. Okay, so if you start from a node and end up reaching back to that node by following some path, then that graph is called a cyclic graph. And on the other hand, if suppose I drew another graph here, this, and this, so this would be an acyclic graph. Or even if I add some cycle node here, still this is an acyclic graph, because starting from this node you cannot reach back to this node. See, starting from this node you cannot reach back to this node by following any of the paths that it has. Starting from this node you cannot reach back to itself following any path. So this is the difference between cyclic and acyclic graphs. Okay, never mind this. Okay, this is just an example of where it is used, and no cycles are present acyclic graph. In directed graphs, these are called directed acyclic graphs. Okay, then we have based on connectivity, connected graphs and disconnected graphs. Now let me just draw a connected graph. These are both examples of connected graphs, because you can, starting from any vertex, all the vertices are connected to each other. Starting from one vertex, you can traverse to any of the vertices in the graph. That's what we call a connected graph. And now see, this is a graph. I have drawn a undirected graph, and if I add a vertex here, then this is not part of this is not connected to any of the other vertex. So this graph, we'll call it as a what? Disconnected graph. These are connected graphs, and this is a disconnected graph. Disconnected. I'm just trying to write, but okay, let's just leave it to here. This. So, and we have two more types remaining. The first one, these are edge density, based on edge density. So we have graphs based on edge density. We have sparse graphs. Like we have learned about sparse matrices, where there are zeros and ones, more zeros and less ones, or less other numbers. So similarly, if a graph has less edges, then the number of vertices. That is what we call a sparse graph, and if it has uh, more edges than compared to the number of vertices, then that's what we call a dense graph. That's what is mentioned here. See, if the number of edges is very less than the number of vertices, then that is what we call a sparse graph, and many edges, then we have a dense graph. There are few special graphs here. These are a complete graph. What is a complete graph? If I draw a graph here, and if I make connections from one vertex to every other vertex, from this to this as well, to this as well, then from this to this as well. So if a graph has connections to every other vertex, if a vertex has connection to every other vertex in the graph, and this condition being valid for all the vertices present in the graph, then that graph is called a complete graph. Now for an undirected graph, the number of edges in a complete graph will be, see, for this edge we'll have 1 2 3 connections. Okay, for this 1 2 3, for this 1 2 3. So what we have is, if there are k vertices, then we have k into k minus 1, because that vertex itself will not be counted. K minus 1 divide by 2. Why do we divide by 2? Because this edge, for an undirected graph, this edge will be counted for 1 as well and 2 as well. So that's why we are dividing here by 2, so that this graph, because in multiplying this term, in getting this term, this edge will be counted twice. That's why we have divided it. Simple as that. Now we have regular graph. These are just, I have mentioned special graphs which are important in like from the point of view of questions. Like these terms are mentioned in the questions, and if you don't know what they are, like they'll be defining, but if you know, then it will be good for us. Okay, so what is the regular graph? Like every vertex has the same degree. What is degree? Degree is the number of outgoing edges from a vertex. Okay, so if I draw this graph and I make two edges from this graph, two from this, two from this. Okay, so every node has two outgoing edges, or two edges in total, 1 2 1 2 1 2 1 2. So this will be a regular graph. This is what we call a regular graph. So that's it for the first lecture. See you in the next lecture, guys, and thank you. And your feedback is very much appreciated. How can I improve this? And if I committed any error during this lecture or in any of the upcoming lectures, then your feedback is much welcome, and I'd like to grow with you all. Thank you. See you soon. Bye. Now how do I stop this recording? Bye.